So without further ado, let us start with our keynote address from Molly Morgan, the Senior Research Analyst at Exawatt. Molly will talk about the latest product and technology trends at SNEC and Intersolar 2024. Welcome to TaiyangNews, Molly. The floor is yours.
Thank you, Anu. I'll just share my screen. I've just tried to share again, so if that's working now, I'll carry on.
Yes, it's working now.
Okay, fab. Sorry about that.
Yeah.
So first things first, here's what you can expect to hear from my talk today. I'll start by setting the scene and discussing the different technologies of today's market, and I'll detail why TopCon currently dominates market share and will continue to dominate in the near future. Then we'll continue this discussion onto product innovations and innovation trends that were seen at SNEC Shanghai and Intersolar Munich 2024 by the CRU Solar PV team. Then finally, I'll end the talk by discussing what comes next in terms of technology innovations and where the progress of tandem modules stood at SNEC and Intersolar. So firstly, to set the scene on the technologies within the PV market. The graph on the left here shows CRU's estimates and forecasts of market share by production of the mainstream technologies from 2016 out to towards the end of the decade, so 2029. You can see that in around 2018, the industry went through a technology transition from BSF to PERC cells. And you can also see that the industry is currently in the middle of a rapid transition to TopCon, with TopCon rapidly gaining market share from the previously mainstream mono PERC. These transitions occur and can occur rapidly when a technology can offer performance improvements at cost parity in comparison to the current mainstream technology. And at CRU, we're able to forecast when these technology transitions will occur by combining our manufacturing cost forecasting from our in-house bottom-up cost model with our efficiency forecasts. TopCon's dominance of the market share is also echoed in CRU's quarterly datasheet survey, and you can see that on the right-hand side here, where within the data, you can see that over the last 3 years, TopCon has been doing this transition to being the most common technology within manufacturer datasheet offerings. So from this, we can see that TopCon not only dominates in production, but also the range of products that are on offer in manufacturer portfolios. So as I just mentioned, technology transitions, they occur when improved performance can be offered at cost parity. So what is going to enable TopCon to keep this market share? On the left here is an extract from our solar technology and cost service, which shows the advantage of the TopCon technology in terms of efficiency over the previously mainstream mono PERC. But the story isn't complete with efficiency alone. And as you can see, TopCon is outperformed in terms of maximum module efficiency by the back contact technology, which is the XPC on the right-hand side there, and also has a broadly similar efficiency spread as heterojunction. But for the heterojunction technology, CRU does not currently believe that HJT will be able to compete with TopCon for significant market share due to the higher associated manufacturing costs. And continuing with the example of HJT, from our internal cost model, we forecast heterojunction to maintain this cost premium of at least around 1.5 cents per watt over TopCon, meaning that heterojunction technology would have to improve in terms of efficiency by over approximately sort of 2.5%, which we currently think is unlikely to be achieved by the technology. Therefore, we can conclude that we don't think heterojunction is likely to compete with TopCon for market share on the large scale. As such, on the right-hand side of this slide, I'm showing cell capacity announced expansion plans. And what is hopefully very clear to see is that TOPCon has capacity expansion plans which are far larger than the other advanced technologies, so hex junction and back contact again shown here. And by the end of 2024, we forecast that TOPCon's cell capacity will have exceeded 1 terawatt of capacity. So to put that into context, CRU forecast between 515 to 575 gigawatts of solar PV installations globally in 2024. At SNEC and Intersolar, bringing it back to the trade shows of this summer, there were little to no surprises with the technology on display at the shows, with lots of TOPCon modules on display reaching higher efficiencies and higher powers, and also some hex junction and back contact modules on display. But in terms of product innovation, we did see lots of innovation through things like architectural design improvements, which I'll now go on to. So the first product innovation I'll discuss today is through wafer formats. Over the past 3 years, we've seen manufacturers turn to using larger and larger wafer formats to achieve physically larger modules and in turn higher power ratings and then higher module efficiencies. On the left-hand side of this slide here, we can see how the average module area within CRU's quarterly datasheet survey was increasing over the past few years. And this was gradual for a few years up until 2023, where the larger format M10 and G12 wafers rapidly became the mainstream wafer sizes within our dataset. At CRU, we don't anticipate average module area to meaningfully increase further, so maybe a few small increases, but nothing like the jumps that we saw in 2023. And we believe this because the industry has now mostly transitioned to using larger format wafers. And in Q2 this year, so Q2 2024, approximately 95% of the modules in our dataset were using the larger format M10 or G12 wafers. And you can see how that's distributed between the other wafer formats and how that's increased on the right-hand side of this slide. However, there were still innovations with wafer format on display at both SNEC and Intersolar 2024. And manufacturers have been turning to using rectangular wafers in attempts to improve module efficiencies through higher outputs and also have improved packing and shipping metrics. And though conversations with industry contacts and seeing the modules on display at the events, it was clear to see the huge range of different rectangular wafer formats on offer. For example, these included wafers with side lengths of 182 and 210 millimeters, but also different side lengths of 182.75, 182.2, 191.6, and the list goes on. So although we've standardized to the industry mostly looking at M10 and G12 wafers, with the product innovation of the offering of rectangular wafers, there's lots of available module wafer dimensions on offer today. So continuing with product design innovation, following overproduction throughout the supply chain in recent years, inventory build has led to strong downwards pressures on prices. So throughout the supply chain, manufacturers have been looking for ways to reduce costs. And as such, cost reductions were a big driver of product innovations and trends on display at SNEC and Intersolar Munich this year. So I'll use frames as one example of this. And with the frame price structure shown here, you can see that the price structure is dominated by materials costs, which today is most commonly aluminium. By leveraging CRU's commodity and aluminium price forecasting, we believe that aluminium prices are set to rise in the coming years, which is another reason why manufacturers have turned to investigate the use of alternative frames to aluminium. On display this summer, our team saw both steel and composite frames on display, And through conversations with industry, we were led to believe that these alternative frame materials could offer savings of 10 to 30% of the frame cost by using aluminium alternatives. And our internal cost modelling agrees with the lower end of this estimate. So frame savings of around 10% by switching to alternative materials like steel and composite frames. Another innovation on display from numerous materials and equipment suppliers was zero busbar modules. And I know that's been discussed a bit yesterday. And these have the advantage of a reduced silver usage. And we believe this is in the range of 20 to 40% compared to multi-busbar solutions that you see today. However, these offerings of zero busbar modules, although there were some on display at the trade shows, these are still in development, and through discussions with manufacturers at trade shows, we believe that there are very little that are in mass production with zero busbar designs. But we expect to see these modules gain traction in the next few years, and so this is definitely an innovation that you can expect to see more of in the industry over the next year. Okay, so now let's look to the future and see what technology innovations are on the horizon. TOPCon does have some technical limitations that may stop the technology remaining competitive in terms of efficiency. And these include things like finding a way to put TOPCon on the front side of the cell rather than just the rear side. And this is a key R&D focus for manufacturers currently. If this TOPCon passivation on the front side of the cell proves too difficult or too expensive to do in mass production, we can expect to see heterojunction and back contact technologies gaining market share more rapidly. In the longer term, we do expect to see a transition to tandem cells and modules. But despite seeing some manufacturers showcasing their first products and their first tandem products on display at SNEC and Intersolar, these, similarly to the zero busbar design, they're not yet available in mass production and not commercially available. And the timescale for these remains somewhat uncertain. We think that it's likely that in 2027, we'll see the launch of perovskite silicon tandem cells at relatively large scale. However, this does rely on manufacturers reaching their own internal targets. As such, we at CRU, we anticipate a large-scale shift to tandem cells to be likely more in the 2030 to 2035 timeframe. And the longer that this large-scale launch of tandem cells takes, the more likely that it is that the back contact technology with its high efficiency will bridge the gap between TOPCon and tandem modules as manufacturers strive to drive the industry forward through performance advancements and through achieving higher efficiencies. So to recap what we've discussed today and what innovations were on display at SNEC and Intersolar 2024, we've set the scene and we discussed why TOPCon is the mainstream technology of today and what currently prevents other advanced technologies like heterojunction and back contact from rivaling TOPCon's dominance of the market share. Then we've discussed that there were no large surprises in terms of the technologies showcased at SNEC and Intersolar with a focus on TOPCon and ways to achieve higher efficiencies and higher power ratings of the existing technologies. But what we did see in terms of product innovation was products showing innovative trends with wafer formats, so that's the rectangular wafers, and then the frame and busbar design, where manufacturers were using innovations to try and drive down costs. Then finally, we've looked at what technology transitions will come after TOPCon. But despite some modules being on display at SNEC and Intersolar showcasing tandem cells, we don't forecast large market share for the technology until the early 2030s, after we've given time for capacity to ramp and the products to be commercially available. So I'll leave it there for today. And if anybody has any questions, please feel free to get in touch or use the Q&A. But I will hand it back to Anu now.
Thank you, Molly. That was a very comprehensive and very interesting presentation. So just one question from me. You mentioned that HJT will have it hard to gain market share because they would need some 2.5 percentage points higher efficiencies over TOPCon to compete. So how do you see it for back contact technology, because their efficiency currently is really high?
Yeah, so it's almost the next step along in terms of back contact does offer the higher efficiencies in comparison to TOPCon and heterojunction. But unfortunately, at the moment, these do come with the higher manufacturing costs, so cost more to the end user. However, that doesn't mean that back contact isn't great for some niche and some particularly residential applications. It just means that until costs can be driven down and achieved at a closer price premium to TOPCon, it may remain a niche application for the next few years.
All right, we'll probably take it up more in the panel. Thank you so much. I would
Thank you.
Please join the chat room where you can carry forward this discussion with the other attendees.
Thank you.
Thank you so much.